Hello students, welcome to my maths class. I am Anoop Massey, your maths educator on this platform. Okay, before we start with the class, I want to share with you what's new with Unacademy. Well, here in Unacademy, you can ask a doubt. So, what's new about here is that you can ask your unlimited doubts, right? You can ask unlimited doubts. Moreover, you will get a high quality video in solutions in English and Hindi. You can obtain an instant and accurate solution of the questions. You can ask a doubt at any time. You can receive exact matches for the questions, and you can get assistance with homework also. So this is all new about the Unacademy. How to ask a doubt. So here we have given you the steps how you can ask the doubts. So you can go through these steps and confirm how can you ask the doubt. Then we have okay, now here I have given my referral code AMSIRUP, and using this referral code you can get 10% off on Unacademy Plus. So for this subscription, you can use my referral code AMSIRUP. This is my referral code, so remember this, and then you can get a discount. So what today we are going to discuss? We are going to discuss about the surface area and volume of solids like cylinder, cone, sphere, and we will also try to cover up some from the solid like cube and cuboid also. We will try to cover some portion of it. Now before we start on, let me explain you on this few formulas, how the formulas to be used, right? So let me explain you few of the formulas. So first of all, I would like to explain you formula for the cylinder. So first of all, let us consider a solid cylinder, right? I will explain you few of the formulas on solid cylinder. Because before entering into the questions, I would like you to remember these formulas. Cylinder. Now, a solid cylinder, as you can see, if you draw a rough sketch of a solid cylinder, so you can say that there are three surfaces in a solid cylinder. We will find three surfaces in a solid cylinder. Okay, what are these three surfaces? You see, we get a circular surface on the top. We get another circular surface here at the bottom. So two circular surface and this surface, which I am going to mark with some other color like yellow one. So this is called the curved surface, which I am marking in yellow. This is called the curved surface. This is called the curved surface, right? So we have these surfaces here. So all together you can say we have the three surfaces here. Now remember, from this surface to this circular surface, this distance, this is called height of the cylinder. This is called the height of the cylinder. Now as I told you, it has a circular base, so whatever will be the radius of this circular base, that is known as the radius of the cylinder. So all over we can say that cylinder has two dimensions, height and radius. So we have the formulas based on these two dimensions, right? Cylinder has two dimensions and those two dimensions are height and the radius. So first of all, using these dimensions, I would like to tell you certain formulas. First of all, formula on volume. So formula for volume is pi r square into h. This is the formula for the volume of a cylinder. Remember. Second, we have the formula for curved surface area. Now, how we will get this formula? This is the formula. The curved surface area is 2 pi r into h. This will give you curved surface area, which I have marked in yellow, right? Okay, we have next the total surface area. So what's the total surface area? So there are three surfaces, see. There are altogether three surfaces. This surface which I have marked in yellow, this is called the curved surface and its area is 2 pi RH, right? Then on the top, I told you this is a circular surface, so it will be pi r square. At the bottom here, again I have drawn a circular surface, so formula will be pi r square. So altogether I have got these three surfaces. So if I add these three surfaces, 2 pi RH and two circular surfaces, pi r square and pi r square, two circular surfaces. So if I add all these surfaces, that will be known as the total surface area. So see here, how can I arrange it further? This is 2 pi RH. Now pi r square plus pi r square will give me 2 pi r square, right? So this is the formula, and this can be further arranged by taking 2 pi r common. If I take 2 pi r common, I am left with h plus r. So this is the formula for total surface area. So you have to remember these three formulas. One for the volume of a cylinder, one for the curved surface area of the cylinder, the other one for the total surface area of the cylinder. Hope this much is clear to you. Now, suppose this cylinder is rolled from this position to this position, right? I am rolling the cylinder from this position to this position. A cylinder comes from here to here. Okay, let me draw. Cylinder comes from this position to this position. So when it has moved from this position to this position, you can see it has covered certain area. See, I am marking that area in green. It has covered certain area. Now, if I ask you how many times the cylinder revolved to reach from this point to this and covering the certain area, this area it has covered. So how can you find the number of rotations made over here? So you must note down the formula for that. See, it is coming from this position to this position, so it must be rotating, it must be revolving certain times, maybe 5 times, 7 times, whatever times. So you have to find the number of rotations made by it. So number of rotations. So we can use the formula that whatever the area it covers, right? Area covered divided by curved surface area. So in this way, you can find how many rotations the cylinder will make to cover a certain area. Or in some of the questions, they may ask you to calculate the area covered by the cylinder in rotating certain number of times. So you can cross multiply here and you can arrange the formula for curved surface area. So these are the formulas which are related to the solid cylinder. See? So four formulas I have told you: volume, curved surface area, total surface area, and then the number of rotations. Okay, now we will move on to this was a let me make a space to write here. I will remove this from here and write it over here. Right. So we will get this space. So number of rotations is equal to area covered upon the curved surface area of cylinder. So we can use this formula for calculating the number of rotations. Now coming on to the hollow cylinder. Now suppose the cylinder is the hollow one. Now let's see hollow cylinder. Now see, the hollow cylinder will be somewhat like this. Now in hollow cylinder we have three dimensions. Now what are those three dimensions? Now you see, this is the inner circle you are getting. So whatever will be the radius of this circle, that will be small r. So hollow cylinder has one internal radius. It has one internal radius, which we represent by small r. Then it has external radius like this one. This one will be the external radius. It has external radius. It has internal radius. It has external radius, represented by capital R. Now this will be the height of the cylinder. Let it be represented by h. So we have three dimensions: internal radius, external radius, and height of the solid cylinder. Sorry, hollow cylinder. Three dimension. Now if small capital R and small r, if you make the difference of it, then see, this is the thickness of the material. This is the thickness of the material. So we can get the thickness of the material. So how will you get the thickness of the material? See, so if they ask you to find the thickness of the material in a hollow cylinder, so it's very simple. Small capital R and small r difference. That will give you thickness of material in the hollow cylinder. Now let us see what will be the formula for the volume of material in a hollow cylinder. Volume of material. Now how do we get the formula for the volume of material in a hollow cylinder? Now for that, what we do, we find a volume using the external dimensions, and then we find the volume using the internal dimensions, and we subtract it, and we will get the volume of material. So see what I will do over here. So I will find volume using the external dimension. So see, volume formula is this, pi r square h. So I will be using pi r square h. Then I will find the volume using the internal dimensions. Now the internal formula will be the same, but instead of capital R, you will be using small r now. So pi r square h. So this is the formula for volume of material. Once you will find the volume using internal dimensions, the other time you will find the volume using internal dimensions, and then you will subtract it. So if you subtract it, what you can do is you can take pi and h common. See, from these two I have taken pi and h common. So I am left with r square minus r square. So in this way you can arrange formula for the material in a hollow cylinder. So this is the formula how you can arrange for the volume of material in a hollow cylinder. Now coming to the surfaces of a hollow cylinder, right? So let's see how many surfaces the hollow cylinder has. Let me explain you here. How many surfaces a hollow cylinder has? So let me mark these surfaces with different colors to make you explain. See, first of all, you can say a hollow cylinder has you see a hollow cylinder has this working. Okay, here you see this is one surface which I am marking in yellow. This is one surface. Now this is not a circular surface, but this surface is given a shape of a circular track. It's a track shape, right? Because it's hollow in between, so it's a circular track shape. Similarly, we have one more circular track at the bottom here. So two surfaces are these which a hollow cylinder has. Okay, what other surfaces it has? Let me mark it with some other color. Okay, one it has external curved surface. This one it has external curved surface. One it has external curved surface. External curved surface like this. And the third one it has fourth surface, it has internal curved surface, which I am marking by red somewhat here. It is from inside internal curved surface. So altogether, a hollow cylinder has four surfaces. Okay, so what four surfaces it has? See, one this is a circular track, one this is a circular track. So two circular tracks. So I am writing total surface area of a hollow cylinder. So one circular track. Now what is the formula for a circular track? So it has two circular tracks. Two circular tracks. Okay. Plus one, the green one, which you can say external curved surface. External curved surface. Plus it has internal curved surface. So altogether it has four curved surfaces, right? It has four curved surfaces. So let us write the formula for these. See twice, and now we have circular track. So for circular track, formula is pi r square minus r square. So two tracks. See, for one track it is pi r square minus r square, and then as there are two tracks, so you can write it two times. Plus, then we have external curved surface. So 2 pi capital RH, and then you have one internal curved surface. So 2 pi small rh. So this is the formula that you can arrange for total surface area of a hollow cylinder. So see how can we arrange the formula. So you can note down, can take the screenshot, or you can note down these formulas which we will be using in case of a cylinder. So these are the formulas that we will be using in case of a cylinder. Whether it's a solid cylinder, so I have given you few formulas for solid cylinder, and then we have a hollow cylinder, so I have given you the formula for hollow cylinder. Hope this is clear. You can note it down. You see the formulas that I have given you. These formulas for This clear to you? So these were the formulas for um, the cylinder formula, hollow or a solid one. Okay, now let me explain you few now on the cone. Now let me see first question. Get is based only on the cylinder. So I will explain you the formulas on the cylinder. So you can try this question now. So let's try this question. This question says the area of the curved surface of a cylinder is 4400. This is the area of curved surface. Now remember what do they mean by the curved surface. See, if I am drawing a rough sketch of a cylinder over here, if I am drawing a rough sketch for a cylinder over here, then by the curved surface we mean this portion, which I am coloring green. This portion, this is called curved surface. This is called curved surface. This is called curved surface. So they have given us area of this curved surface. Okay. So what is the formula for this curved surface? Formula for this curved surface is 2 pi r h. So the formula for curved surface. What else they have given? They have given us the circumference. Now let me tell you what circumference is. See this which I am marking in red. This boundary, see this boundary of circular portion, this boundary. This is called circumference, right? This boundary, which I have marked in red, this boundary is called circumference. The formula for the circumference is 2 pi r. This is the formula for circumference. So they have given you two things. What are they? They have given you curved surface area, that is 2 pi rh, as well as they have given you circumference. Okay, let us write the formula for these two. So in the question, they have given us curved surface area 4400. So this is curved surface area given to us. So what's the formula for curved surface area? See, formula for curved surface area I have written here. It's 2 pi r, 2 pi r h is equal to 4400. So I have marked like this. Now let us substitute the values. 2 into, in place of pi I will put 22 by 7. In place of radius is not known to me. Height, you will say height is also not known to you. Okay, so we get on the left side r into h, and on the right side, if I cross multiply it, it's coming like this. Twenty-two into 2 will give you 44. So this will reduce it and give you 100. So RH is equal to 700. Now this is an equation in which there are two variables, so you cannot solve this equation. So let it be marked as equation number 1. Hope this is clear to you. The curved surface area was given. I applied the formula for curved surface area and I am getting this equation. Now what I can do next is, they have given me circumference and the circumference formula is 2 pi r. Okay, so I can write circumference given as 110, right? Formula for circumference is 2 pi r, 110, so 2 into 22 by 7 into r, is equal to 110. So R is 110 into 7 upon 2 into 22. So let's see what will be the radius. 22 will reduce it 5 times. So this will give you 35 upon 2. So this is the radius. Now after getting the radius, but the question says they have asked for the height. So let's substitute the value here. So RH is equal to 700. R we have calculated 35 upon 2. So 35 will reduce it 20 times. So height we are getting 40 centimeter. So we have calculated radius, we have calculated height. This is clear to you? The first part, they asked us to calculate the height. Now, question says, the second part says, find the volume. So let's apply the formula for volume. Volume formula is pi r square h. So pi is 22 by 7. Radius is 35 upon 2 into h, that is height, that is 40. So let's reduce it. 7 reduces it 5 times. 2 to the 4 reduces it 10 times. So let's see what we will get. 22 into 5 will give us 110, and into 10, 1100 multiplied by 35. So 38500. So this will be the volume. So just see this question once again. Is this question clear to you? Here, curved surface area was given, so I applied the formula for the curved surface area. See here. Curved surface area was given, so I applied the formula for curved surface area, and as there are two unknowns r and h, so I am getting equation number 1 in terms of r and h. Then curved surface area is given to us. Then circumference is given 110. I applied the formula for circumference 2 pi r, and I am getting the radius as 35 upon 2. Now substituting this value of radius here, so when I substitute this value of radius, so I am getting the height as 40. And then we have to find the volume. In the formula for volume, let's substitute radius and height, and we will get the volume. Hope this is clear to you now. How to work on the questions based on cylinder. Our next question is again based on cylinder. So let's do this one. A cylindrical tube open at both ends is made up of metal. A cylindrical tube open at both ends. So we can straight away draw a hollow cylinder, right? So let's draw a hollow cylinder. see here a hollow cylinder drawn. Right? Now, they say the internal diameter, see, internal diameter, so you can say small d. This is given 11.2 centimeter. So if I take half of it, I will get internal radius. So you take half of it, so 5.6. That is the internal radius. Okay. Then what is given? Length is given. So we can write the length. So the length of the cylinder, that means the height. If I keep the cylinder in the horizontal portion, so I can say it's the length of the cylinder. So length of the cylinder means the same, the height of the cylinder. So height of the cylinder is 21 centimeter. And the metal thickness of the metal. So we have thickness of the metal. So let's mark the thickness of the metal. So how can we mark the thickness of the metal? See. Now formula for thickness. What I told you the formula for thickness was. I told you in the starting the formula that thickness of the material means capital R minus small r. This is the formula. Right. So thickness is given to us 0.4. Keeping the thickness 0.4. Capital R is unknown to us, but small r we have already calculated 5.6. Now when this minus 5.6 is transferred to the other side, you can see over here the working, it becomes plus 5.6. So in this way we have calculated the external radius, that is 6 centimeter. See this working, if it's clear to you. So thickness formula is capital R minus small r. So in this formula, I have substituted the value for thickness and small r, which is known to me. So I am getting capital R. Now see, all the dimensions are known to me. Small r is known to me, internal radius, that is. Capital R is known to me, and the height. Everything is known to me. Now they are asking me to calculate the volume of material. Now volume of metal in a hollow cylinder. Now what formula I have told you in the starting. In this case, I told you that once you will calculating the volume using the external dimensions, then you will calculate the volume using the internal dimensions, and their difference will give me volume of metal. Okay, so let's use the formula for volume. Volume formula is pi r square. So pi r square h. Internal, it's the same formula, just small r is replaced with, capital R is replaced with small r. See? Now in hollow cylinder, there is no internal or external height. Height is only one. No internal external height, right? Only the radius. So here I can arrange it by taking pi and h common. So I have taken pi and h both common. So pi will be replaced with 22 by 7. Capital R and small r. Capital R is 6. Now you see this formula can further be rearranged. Okay, let me show you how. In algebraic portion, you must have learned the formula for the difference of two squares, a square minus b square. So using that, we can further rearrange it. See, a plus b into a minus b. Okay, now let's substitute the values. Pi is 22 by 7. capital R is 6, small r is 5.6, capital R is 6, small r is 5.6, and the height is 21, that we have calculated 21. Now before opening this bracket, you see over here, this 7 will reduce this 21 3 times, right? So let it be reduced by it. Now it's 22 outside the bracket. Now within the bracket, when I add these two, it becomes 11.6. And in the second bracket, when I subtract these two, it becomes 0.4. And now you have to do the simple multiplication to get the volume. So you can say volume is equal to, now 22 and this 0.4 into 3. So this will give you 22 into 11.6 into, this will give me 1.2, right? 0.4 multiplied by 3 will give me 1.2. And now you can do the simple multiplication over here and get the result. So I am leaving this calculation for you all to do. It's just a simple multiplication. 22 into 11.6 into 1.2. So you can do this multiplication on your own, or you want me to calculate it for you. Okay. So I will do it. 22 into 11.6. So let me do it here. So 11.6 multiplied by 22. So when I multiply it by 2, it is giving 232 here. And then again 232. So 2552. So it will give me 255.2. So 255.2, then multiplied by 1.2. So let's multiply it. So 12 2s are 24, carry over 2. 12 5s are 60 and 2 62. 12 5s are 60 and 6 66. 12 2s are 24 and 6 30. So 1 2 places. So one answer will be 306.24 centimeter cube. So you can check the calculations later on. It's a simple multiplication that you can do. So this much is clear to you. This so one question I have explained you based on a solid cylinder, and the second question I have explained you based on the hollow cylinder. Okay, let's move on to the next. Just a minute, students. There is a certain problem here. We have to open this file again. Now we have the question based on cone. Now I have a question for you based on cone. So Let's see how we are going to do this question. Now first I will explain you the formulas for the cone. Now let us consider. So let me explain you formulas for cone. Right. Formulas for cone. First let me explain you this. Now let's see how many dimensions a cone has. Now I have drawn a rough sketch for a cone here. Here I have got a circular base for the cone. This is a circular base, and the one which I am going to shade with some any other color. Now this one is the curved surface of the cone, which I am shading in yellow. This is the curved surface area of the cone. This is curved surface area of cone. Right? And this one, this is the circular surface. This is the circular surface. So altogether cone has two surfaces, one circular and one the curved. So if we talk about the dimensions, so then this length, this is called slant height of the cone, which I can represent by L. Now this is known as the vertical height of the cone, which I can represent by capital H. And this is the base, and this is called the radius of the base, that can be represented by R. So it has altogether three dimensions: slant height and the radius. So let's see what will be the relation between these three. So let's see what will be the relation between these three. This is the relation between these three. Okay, so remember this formula first. Then we have the formula for volume. So volume formula is 1 upon 3 pi r square h. This is the formula for volume. Now as I told you, it has two surfaces, circular and curved. So formula for curved surface area, curved surface, it is pi r l. Okay, if they ask you to find the total surface area, so for that what you will do, to the curved surface area, you will add the area of this circular base. You will add area of this circular base, pi r square. So pi r curved surface area is pi r l, circular is pi r square. So this will be the formula, which can be further arranged by taking, here you can take pi common, pi r, so you will be left with L plus R. So this is the formula for the total surface area, which can be further rearranged like this. See. Just see if these formulas are clear to you. You can quickly note down this formula, and giving you 1 or 2 minute time to note it down, because then I will have to rub it and then we will be solving the question. so you can quickly note it down. I've given you these formulas, you can quickly note them down. So see how many formulas we have got here. We have got this formula which is relating the three dimensions. We have got this formula which is for the volume. We have this formula which is for the curved surface area, and then we have this formula for the total surface area. So altogether you can say you have four formulas for this. This much is clear. I am giving you just 2 minute time to note it down. Hurry up, note it down. Okay, so we have to start with this question number 3. Okay, so let's see what they have given. Question number 3, they are saying the volume of a right circular cone is given to us. Okay, so we can say volume is given to us. Volume given to us is 9856. This is the volume of cone given to us. So let's write the formula. It's 1 upon 3 pi r square h. This is the formula for volume. Now in this formula, let us substitute the values. Now radius, now see here, this is the diameter given 28. So radius will be 14. Into height. How much is the height? The height you can say can be calculated from here. So from here you can calculate the height. Now before calculating the height, let's see what can be reduced from here. 7 will be reducing this. Now to calculate the height, what we will be doing? Now we will do the cross multiplication here. 9856 into 3 upon 22 into 14 into 2. See? Now let's reduce it. 22 will go 4 times. 88 carry over 10. Then again, so first we can reduce by 11 straight away. 11. So 11 8s are 88, carry over 10. And 11 9s are 99, carry over 6, 11 6 are. Now what can we reduce it? Now can we reduce with 7, 7 2s are. This will reduce 7 1 is 7, carry over 1, 7 2s are 14, carry over 5, 7 8s are 56. Now 2 to the 4 to the 8, reduce it by 8. So 8 1 the 8, carry over 4, 8 6 the 48. So height is 16 into 3, that is 48. Something looking good. Then we need the slant height, right? So h we have calculated 48 and the base radius is 14. So first of all we need square of 48. Okay, so students, I would like to okay, now again I would like to share with you for the formula for the volume of and surface area of a cone. Okay, now let us consider a cone. So see, I wanted to tell you that a cone has three dimensions, right? So what are those three dimensions that I would like to tell you once again? The three dimensions that the cone has are the height of the cone, we have slant height of the cone, and we have the radius of the cone, the three dimensions of the cone. Now how are they related? See, L square is equal to H square plus r square. This is the relation between them. Right. Now, so this is the relation, this is the first formula that you have to remember, the relation between the dimensions of a cone. Okay, next what you have to remember is the formula for the volume of cone. So volume of cone is 1 upon 3 pi r square h. That is the formula for the volume of cone. What else we have? Curved surface area. Now which portion is called the curved surface area? Let me mark it for you. Then this portion, this is called curved surface area. This portion is called the curved surface area that I have marked green, right? The formula for the curved surface area, it is pi r and L. Pi r L, that is the formula for curved surface area. Now suppose you are asked to write the total surface area. Now if I ask you to write the total surface area, then you will say that there are two surfaces on the cone. See, one which I have shaded green and the other which I am shading yellow. So see, the portion that I am shading yellow, it's a circular surface. It's a circular surface. The formula for total surface area will be the curved surface area plus the circular surface, that is the circle portion. This. So curved surface area is pi r L and the circle is pi r square. Now if I take pi r common, then it will be L plus r. So this is the formula for total surface area. So you have to remember these four formulas that we will be using for solving the questions based on cone. Okay, so now let's try this question based on these formulas only. They say the volume of a right circular cone is this. So volume is given to us 9856. As volume is given to us, so we are going to use the formula for volume, and the formula for volume is 1 upon 3 pi r square h is equal to 9856. Now let's substitute the values. In place of pi, 22 by 7. Radius. So see here, diameter is given 28. This is the diameter given, right? So half of diameter will be radius. So 14 into h, that is the height we have to find. 9856. Right. So here you can see this 7 will reduce this 14, and now you cross multiply to get height. 9856, you cross multiply it with 3 here upon 22 into 14 into 2. So let's reduce it and see what we get. So 11 2s are 11 8s are 88, carry over 10, 11 9s are 99, then 11 6 are 66. Then let's reduce it by 7. 7 2s are 7 1s are 7, carry over 1, 7 2s are 14, carry over 5, 7 8s are 56. Then you can reduce it by 2 to the 4 to the 8. So this will give me 8 1s are 8, Carrying a 4, 8, 6, 48, so I am left with 16 into 3. Okay, so finally what will be the height? So I can say height will be 16 into 3, that is 48. So we have calculated the height. So in the first part they have asked us to calculate the height of the cone. Now moving on to the second part, they have asked us to calculate the slant height. So now this is the relation. So we are going to use the relation L square is equal to H square plus R square. Now in this relation we need to find L square. So you can say H square, that is height square. So height you have calculated 48 plus radius, that is 14. So this will give you 48 square 2304 and 14 square 196. So L square is equal to 2500. Right. So what will be L? It will be under root of 2500. So the slant height will be 50. We have calculated the slant height also. Okay. You see up till here, is this clear? And in the third part, they are asking us to calculate the curved surface area. So CSA, that is the curved surface area, formula will be pi r L. See, formula for curved surface area is pi r L. So let's calculate the curved surface area. So pi will be replaced by 22 by 7. Radius, how much is the radius? Here radius is 14, and the slant height we have calculated as 50. So 7 goes 2 times. So this will give you curved surface area is equal to 2200 centimeter square. So this will be the curved surface area. Just see this. Hope this is clear to you now. So first of all, volume was given. So we applied the formula for volume and we got height. Next they asked for slant height. So to calculate the slant height, we have applied the formula L square is equal to H square plus R square, and we are getting the slant height as 50. Next they have asked us to calculate the curved surface area. So formula is pi RL. Substituting the values, we have got curved surface area as 2200. So this much is correct. Okay, so now let us move to the next question. Let's see on what. Okay, again it is based on the right circular cone. Okay, so if it's based on the right circular cone, so again we can use the same formula. Let's see what's given here. The total surface area of a right circular cone of slant height. So first of all, they have given us slant height, that is L. Slant height is given 13. And they have given us the total surface area. Total surface area is given to us in terms of pi. So it's given 95. Total surface area. Right. So what else they have given? So they have given us slant height, they have given us total surface area, and they are asking us to calculate the radius and its volume, and pi is to be taken this much. Okay. total surface area is given. So let us first of all use the formula for total surface area. The formula for total surface area is pi RL plus pi R square. Hope you remember this. This is the formula for total surface area. Now let us substitute the values on the left side. On the left side, total surface area is given this 90 pi. Now on the right side, you can take pi r common. So it's L plus R. Now before substituting the values, as you can see on the both sides, pi cancels out. So cancel out pi. And now you can substitute the values. So the left side it's 90. On the right side, the radius is unknown to us. So let it be R. Slant height is given to us as 13 and then plus R. So if you open here, you will see we are getting a quadratic equation. So what we are going to do, we are going to solve this quadratic equation to get value for R. This is the quadratic equation. Now you must be knowing there are three ways of solving a quadratic equation. You can solve the quadratic equation by factorization method, by the square method, or even you can solve it by cross multiplication. Okay, I'm going to solve it with factorization method. Now let me see what the product is required. So if I write it down over here, then the product means multiplication of that. So I can say the product required is 90 and it is negative. So if product is negative, so I will write sum. Sorry, difference. Product is negative, so I'm going to write difference. And whether it's sum or a difference, you always have to choose the middle term. So middle term is 13. Now what information we get from here? The information that we get from here is we require two numbers whose product will be 90. Whose product will be 90, but difference of those two numbers should be 13. Difference of those two numbers should be 13. So we can say the two numbers are 18 and 5. See, if you multiply 18 and 5, you will get 90. But if you take difference of 18 and 5, you will get 13. So what we are going to do, we are going to split this middle term. So here 13 will be replaced by 18 minus 5. Why minus 5? Because this is a difference. So you have to put difference of these two. 8 minus 5 here in place of 13. So let's see what our equation will be. So our equation will be like this now. R square plus in place of 13 you will be substituting 18 minus 5. Now see what will be the result. R square plus, now if I open the bracket, it's 18R minus 5R minus 90 is equal to 0. Now if I take R common, then R plus 18. Now here I take 5 common, so again R plus 18. So R plus 18 into R minus 5. So you have got these two factors. So let's solve this quadratic equation. So the first factor R is equal to minus 18. If we equate the second one, it gives us R is equal to 5. So we are getting radius minus 18, radius plus 5. So radius cannot be minus, so that means you are going to choose this value. So the correct, you will ignore this value because radius cannot be negative. So in the first part they have asked us to calculate the radius, so that we have calculated. Now let's see what they are asking in the second part. It's volume. So volume formula is 1 upon 3 pi r square, right? Right, so what will be volume? 1 upon 3 pi will be replaced by radius, we have calculated 5, and the height is already, no, height we have also calculated. No, now height is not known to us, so that means first we need to calculate the height. Okay, so let's calculate the height. So how do we calculate the height? We will apply here the relation. The relation is L square is equal to h square plus r square. Now why are we calculating height? Because when we wrote the formula for volume, there you can see height is required. So as height is required, so first we need to calculate the height, right? So we are calculating the height first. Okay. So L slant height is given 13. Height we have to calculate, and radius is 5. So 169 minus 25, 144. So you are getting h square is equal to 144. So you can say that height is equal to 12. So we have calculated the height. Now let's apply the formula for volume. So 1 upon 3 into pi. Now as the question says, pi is to be used as 3.1416 into radius 5 square into height, that is 12. So V is equal to, now this 3 will reduce 12, so it is 3.1416, 5 square is 25, and this 12 will be reduced by 3, 3 fours are, so into 4, okay. So volume will be 3.1416 into, now 25 into 4 will give us 100. So volume is equal to, when I multiply it by 100, 314.16. So this will be the volume. Okay. So this question is clear to you now. This you can see it once again. The total surface area of the right circular cone of slant height. So slant height was given to us as 13, and the total surface area was given 95. So we have applied the formula for the total surface area. It's 95. So on applying the formula and doing the calculation, we are getting a quadratic equation in terms of r. So we will be solving CC. We are getting a quadratic equation, this quadratic equation. R square plus 13r minus 90 is equal to 0. We will solve this equation by factorization method, that is splitting the middle term. So we are getting these two factors, and when equating these two factors with 0, we are getting radius as minus 18 and 5. Now radius, r is radius, that cannot be negative. So neglect this value, consider the positive value. After that, the question says we have to calculate the volume, and for volume we need the height, which is not known to us. So we have applied the formula. L square is equal to h square plus r square, and this formula will give us the height. Now substituting this value, and we will get the volume. Hope this is clear to you how to calculate the surface area and the volume of cylinder. We have done few questions on cone also. Now let us see what's the next question. Now it comes the sphere. Now before starting with the sphere, I would like to share with you the formula that we will be using for sphere. Okay, let me tell you. If it's a sphere, means a solid sphere, right? Now, whenever a sphere is solid, it is called a sphere, and when it is hollow, then it is called a shell. If it's a solid, then it is called a sphere. Remember, you can simply call it as a sphere. No need to write solid, because when it is solid, then only it is known as sphere. If a sphere is hollow, then it is called a shell. Now, sphere has only one dimension. See? A sphere has only one dimension, and that is the radius. So let's see what will be the formula for volume. 4 upon 3 pi r cube. This is the formula for the volume of a sphere. 4 by 3 pi r cube. Now if I consider sphere has only one surface. This surface. You can call it curved surface. You can call it just simply the surface. You can call it as total surface. Whatever you want to call, it has only one surface. So whether you call it curved surface or you call it total surface, it will make no change in its formula. It will be the same. So you can write it as total surface area. You can write it as the curved surface area, and the formula is 4 pi r square. This is the formula for surface area, or you can say the total surface area. You can call it as the okay. Now if I cut the sphere into equal parts, right? If I cut the sphere into equal parts, see, this was a sphere. If I cut it into equal parts, so I am getting a hemisphere like this. If I cut a sphere into equal parts, I get a hemisphere. This is called a hemisphere. This is called a hemisphere. So now I'm going to tell you the formula for a hemisphere. Hemisphere, that is the half of the sphere. So I'm considering this portion. Now if I ask you how many surfaces it has, hemisphere, so you will say one, it has this circular surface, this, and one, it has the curved surface like this. So a hemisphere has two surfaces. Okay. Now if I ask you to write the formula for volume of hemisphere. Now hemisphere volume will be half of the sphere. So sphere has 4 by 3. So this will be 2 by 3. Half of it. Pi r cube. This is the formula for the volume. Now if I ask you how many surfaces a hemisphere has. I am removing one of the hemisphere because we are the same formula you are going to use for both. Now if I ask you how many surfaces, so you will say it has one, this surface which is called the circular surface, pi r square, its area. One, it has curved surface. This curved surface is half the curved surface of the sphere, that is 2 pi r square. So remember, a hemisphere has two surfaces. One is a circular surface and the other one is the curved surface. So if I ask you to write the formula for curved surface area of a hemisphere, so you are going to write 2 pi r square. And if I ask you to write the total surface area, so you will be adding these two surfaces, that is the curved surface and the circular surface, you will add them, and this will give us 3 pi r square. So here I have arranged three formulas, so let me mark these formulas for you. One formula I have arranged this one, that is the formula for volume of a hemisphere. One formula I have arranged this for you, this is called formula for the curved surface of a sphere, and this is the formula which is called the formula for the total surface area. This is the formula for total surface area. So these three formulas I have arranged for you for hemisphere. Now based on this formula, let us try this question. They say the surface area of a solid sphere. So this is the surface area 4 pi. So they have given you surface area of a surface area of a sphere. So let's see what is the formula for the surface area of a sphere. It is 4 pi r square. This is the formula. Now surface area of a sphere is already given 12156. So 1256. On the right side I have 4. In place of pi I can put 3.14 into r square. So from here I can calculate the radius. So let's see what will be radius. So I have 1256 upon 4 into 3.14. So if I remove the decimal, it's 1256 into 100 upon 4 into 314. So r square will be c. So here I can write r square is equal to 1256 into 100 upon, if I multiply these two, 16 carry over 1, 5, 4 3 is 12. This will cancel out, so you are getting r square as 100. So what will be r? So r will be under root of 100, that is 10 centimeter. So I've got the radius. See, I have calculated the radius. Okay, now the question says find the total surface area and the volume of a hemisphere. So for one part, this hemisphere, you have to calculate the total area. The formula for total surface area of a hemisphere. You see here we have the formula for total surface area of a hemisphere is 3 pi r square. It's 3 pi r square. So let's see what will be the total surface area. 3 into, in place of pi, we have to put 3.14 into r square, that will be 10 square. So when you multiply, this will give you 3 4s are 12, carry over 1, 3 1s are 3 and 4. So it gives us 9.42 into 10 square, that is 100. So the final answer will be 942 centimeters square. That's the total surface area. So in the question they have asked us to calculate the total surface area of a hemisphere, and the formula is 3 pi r square. So this is clear. clear to you now? On the next, what they have asked is volume. They've also asked us to calculate the volume. They've also asked us to calculate the volume. Okay, so formula for volume is 4 by 3 pi r cube. So applying it in the formula, 4 by 3. In place of pi, I am going to take 3.14, and then it's r cube means 10 cube. Now when multiplied by r cube, this will become 3140. Okay, sorry, this was, one mistake we have done. This was a hemisphere, not a sphere. This was a hemisphere. Okay, this mistake. So this should be 2. Wait, make the change. This should be 2. So 2 by 3 pi r cube, because they are asking, see here, total surface area and the volume of a hemisphere. So we have to apply the formula for the volume, 2 by 3 pi r cube. So this is 1000. When you multiply by 1000, this becomes 3140. And now multiply by 2, this will give you 6280 upon 3. You want to convert it into fraction or you want to convert it into volume, it's up to you. So this is 2 3 is 6, 0, 2 9 is 27, 3 1. So you can write it like this in decimal, right? So this will be the volume of a hemisphere, not for the sphere, but they have asked us to calculate the volume of a hemisphere. Hope this much is clear to you. And let's move on to the next question. What we have. Okay, the next question, they say a dome of the building is in form of a hemisphere. Okay, the dome of a building is in the form of a hemisphere. So see, the rough sketch shows that this is the dome of a building which is in shape of a hemisphere like this. A dome of a building is in the form of a hemisphere. Now they say from inside it was whitewashed at the cost of, and this is the rate given to you. Find the inside surface area and then the volume. Now its radius is unknown. Radius r is unknown. The question says it was whitewashed. Now when we are whitewashing it from inside, that means only this curved part will be whitewashed. Only this curved part will be whitewashed from inside, this curved part. So as you can see in the question, they have given us this is the cost and this is the rate. So let's write the formula for the cost. Cost formula is rate into area. So here we will get that area which was whitewashed. And which area was whitewashed? That was the curved surface area. So the cost is given 154. The rate is given 2. And from here you are getting the area which is whitewashed. And which area was whitewashed? You will say curved surface area. So from here I am going to get curved surface area. So it's getting me 77 meter. Curved surface area is meter square. So curved surface area I have got 77. Okay. Now they say the inside surface, so I've got the curved surface. Now they are asking for the volume. Now to calculate the volume, first I need to calculate the radius. So how will I do that? You will say curved surface area of the dome is known to you. Now formula for the curved surface area of a hemisphere. See, this is a hemisphere and we are finding only the curved surface area, not the total. Formula is 2 pi r square. Okay, let's solve this. Pi is not given, so I am going to use pi as 22 by 7. So let's do the cross multiplication here. So r square is equal to the 7 will go up, 2 into 22. Okay, so let's see what we are getting r square as. Now let's see what it can be reduced here. 11 will reduce this as 4, 11 will reduce as 7. So in the numerator place, you are getting 7 7 is 49, and in the denominator place, you are getting 2 2 is 4. So what will be the radius? So you will take under root of this, because this is the value of r square. So you will take the under root, so 7 by 2 centimeter. This is the radius. So from the surface, see, when the cost and the rate was given, we calculated the curved surface area. Then we applied the formula for curved surface area and we got the radius. Now the last part says calculate the volume of air, means volume of this dome. So volume formula is, this is a hemisphere, so 2 by 3 pi r cube. Pi is 22 by 7 and the radius what we have calculated is 7 by 2. So it is r cube, 7 by 2, 7 by 2, 7 by 2. So what can be cancelled by this 7? So nothing more than this can be cancelled. In the numerator place I am left with 11 into 7 into 7, and in the denominator place 2 into 3, that is 6. Let's see what will be the volume. 11 into 49. So this is clear to you? So you can solve it. 49 1 by 49. 5 by 4, 49 1 49 and 4 53. So this will be the volume. You want to convert it into like decimal part, so you can convert it into decimal part. But if you want to leave it like this, let it be like this only. It's up to you. Okay. Before ending to this class, I would like to share with you few formulas for the next topic, and that is we will be doing those two solids in the next session, that is volume of cube and cuboid. So first of all, volume of cuboid I want to tell you. Cuboid. I will just discuss the formula and the next time I will make it. Volume formula is it has three dimensions, length into breadth into height. Now if I ask you area, surface area, so that will be twice length into breadth, breadth into height plus height into length. This is surface area. Now if they ask you to calculate the area of four walls, only the lateral surface, twice length plus breadth, twice length plus breadth into height. This is the formula for area of four walls. Now in a cuboid, like this. In a cuboid, we have a diagonal. So they may ask you the formula for the diagonal. I'm writing it here. The formula for diagonal is B is equal to under root L square plus breadth square plus height square under root. This is the formula for diagonal of a cuboid. So we will be using these formulas in the cuboid. Then we have few formulas for the next solid, that is cube. What will be the formula for cube? Volume formula. Now cube has all the sides equal, length, breadth, height. So instead of giving them the name of length, breadth and height, we give them edge, or we call them side. So we say volume of cube is A cube. And if I ask what is A, so you can say A is equal to edge or the side of the cube. So this is the formula for volume of a cube. Then we have the formula for surface area. It has also got six surfaces just like cuboid, and its formula is 6a square. Then we have formula for the diagonal. Diagonal formula under root 3 into a. This is the formula for diagonal of a cube. So the next time we will be doing few questions on cuboid and cube, the remaining two solids. In this session we have done the three solids: cylinder, cone and sphere. For the next time